Good evening, finally, my dear lovely warriors. This is your Captain Shreyas on the Vedantu JEE English channel. I hope I'm audible, visible for all of you, and I hope you have marked your attendance as well. Yes, today we are heading towards the next chapter of your ROAR series, which is your one-stop, series for JEE preparation in pure English on this channel with concepts, applications, and problem solving with the PYQs as well. Yep. And today we are going to complete center of mass and the motion of center of mass. That's a very, very important chapter. And I usually call the center of mass chapter as a silent killer because the concept of center of mass might be used in some other chapter and you won't even realize that, oh my God, I had to use this. That's why center of mass is actually a silent killer chapter. All right. So let's tackle this silent killer with none other than your Capto, your Captain Shreyas, your physics teacher, and been there doing this for a very, very long time. And now it's time for me to send you in your best dream colleges. So stay tuned on the JEE English channel by subscribing and show your love and support by liking. If you have not given your Guru Dakshina, do that right away, right now. All right. So, hello Joseph. Hi Nani. Hi Tanusri. Sir, this video will be helping the NEET student. Yes, you can watch it, but I am conducting separate classes for NEET students on the Vedantu NEET English channel as well. So, you can watch that as well. All right. Hi Sidhu. Hi Fulbert. Good evening, my dear students. And let me also remind you, as you are watching this particular video of center of mass, the entire playlist is also updated. But in case you have any difficulty in finding any of the videos, then remember the Jungle Book is always there. The Jungle Book is a collection of all the videos of whatever I have been teaching you. And it has the PDF, the DPPs, everything, okay, in one place. And remember, the MVSAT examination, the scholarship entrance, the biggest scholarship entrance, online plus offline, both options available. This scholarship test has to be given by every student, whether you are in Vedantu, outside Vedantu, just coming here for some classes, give it, because there are a lot of goodies which you will win just for participating. Plus, if you do well, a lot of prizes to be won, and who knows, if you are in need, you might take up that scholarship for enrolling in so many courses at Vedantu. All right. So do recommend your friends as well or your neighbors in case you have already enrolled and you see that there is a person who has not yet enrolled. So just let them know to compete in the biggest scholarship entrance examination, both online and offline, starting very soon in September and till October mid. You just have to register using your mobile number and you will get all the details on your mobile and your email as well as the Vedantu dashboard, right? Cool. So let's begin with the class, starting off with this concept of center of mass. Yep. Now, let's say I want to balance this pen. Obviously, if I hold it here, it will fall down. But if I carefully probably place it somewhere over here, you can see that I'm able to balance it. Probably, why? Because what is happening is the masses are there everywhere, but there is a point on the pen where I can assume the entire mass of the pen to be concentrated. So, if the mass is concentrated somewhere over here, that means I am just keeping that point over my finger and I am able to hold that particular pen. So, center of mass is basically that particular point where the entire mass can be assumed to be concentrated. And if you hold at that particular point, that object will be balanced. You will not see it will topple or it will fall. You will not see that happening because you have just assumed it to be a point where all the mass is concentrated and you are just holding it or, pinching it or just, supporting it exactly at that particular point. So that is the concept of center of mass. Now, center of mass, the true application I'll tell you now. Let me give you one more interesting example before going ahead. Imagine there is a bottle like this or some bat like this. Somebody gets angry and they throw this bat. Usually, if you see, a particle being thrown under the influence of gravity, if you throw it at an angle, it will go in a curved manner. We have studied this in kinematics 2D, basically projectile motion. Now, if you assume this particular bat to be a point mass, probably that point mass will be somewhere over here. This is where the center of mass of this bat is, that is where all the mass can be assumed to be concentrated. You will see that is the point which basically goes in this particular manner, like this. Whereas the rest of the bat might swivel, rotate, do whatever it wants. So probably after some time, maybe your bat is here like this, maybe. After some time, maybe the bat is here. After some time, maybe bat is here, maybe like this. But it is the center of mass which follows this particular path. So the center of mass follows the path of a point mass under gravity, under the influence of gravity. Basically, that is the parabolic path. That is the parabolic path of the projectile, That's what the center of mass will follow. If you sit on the center of mass, imagine you are an ant or an insect and looking at the bat, what will you see? Can you comment it in the chat box? No problem, Harboran, just started. Yeah, JEE aspirant, it's dropper. Actually, I got some percentage. My dream is to get into. Please give suggestions. Explain me clearly. JEE aspirant, I'll just come to your question towards the end of the class. Just remind me. Let me not break my thought flow. Yep. So, guys, what do you think? Will a person sitting on that point mass C, on that center of mass C, that person will see that the bat is revolving, that the bat is rotating basically. So, with respect to the center of mass, the motion the bat performs basically rotational motion. That is very interesting, and that is also important for us to understand that if you take any point on the bat, let's say this point, which is the handle, it is going like this, then maybe like this, and then maybe like this. Whereas some other point on the bat, maybe this one, is probably going like this, like this, like this. So every point is going in some twisted manner. All other points have a curved motion, curved complex motion, which then becomes difficult to analyze. If I had to analyze the motion of this point or that point or the another point, it will be really twisted and curved, which is not so easy to understand. But center of mass makes it simple. I say that there is a point on the bat which does parabolic motion, basically projectile motion. If you sit on that point, every other particle is doing circular motion. Circular motion we have studied in the circular motion chapter. So, combining both these motions, I can find the location and the exact nature of the motion of any particle on that body. So, the concept and the understanding of center of mass helps us break down any complex motion into, simpler motions. Like one is the motion of the center of mass, and the second one is the motion with respect to the center of mass. So that is the main, I would say, application, or rather the hidden concept or the silent killer concept in the chapter of center of mass. So there are many such examples. Imagine imagine there is something like this. Imagine there is something like this. Say for example, okay, we'll do one thing. We'll take a spring mass system. A spring mass system. It is compressed and it is released on a smooth floor. You know, it will go like a caterpillar motion. This is compressed. It is compressed and released. So it will go like this. It will go like this. So the motion is so complex. But if you look at the center of mass, probably the motion will look very simple. The center of mass will move in a straight line. Whereas if you sit or make yourself positioned on the center of mass, each of the other two masses will go back and forth. Basically, it will oscillate. It will basically oscillate. Even this mass will go back and forth. It will oscillate. So again, a complex motion has been broken down into motion of the center of mass, and with respect to the center of mass, I am seeing oscillations. So that makes it look simple. So I can say the concept of center of mass helps to understand complex motion of system of particles, if there are many particles or different bodies, by breaking it down into two parts. One is the motion of the center of mass, and next thing is the motion with respect to the center of mass. That's what it helps us build the understanding as. If this much is clear, give me a thumbs up, smash the like button quickly. Is center of mass the point where the gravity acts on the particle of the object? Not really. It is the center of gravity, and there is a small difference between center of mass and center of gravity. I'll come to it. That is another misconception which many students have. Is center of mass the same as center of gravity? Okay, let me be very, very clear. What's the difference between the two? Good, you asked. Over here only. Anyways, I would have come to that point. Say for example, we'll take a body. Say for example, let's take a body. Let's say this is our body. Same body I will probably draw over here. Now maybe there is more mass concentrated here. It is more dense on this part. Okay, maybe this part is more dense and this part is even more denser. Same thing over here. This part, the lower part is made of an alloy maybe. The alloy is heavier here and this part is even more dense. If you ask me where the center of mass is, well, I will say the center of mass will be probably somewhere over here. Okay, the center of mass might probably be somewhere over here. Is that right, everyone? So probably use a different color. The center of mass probably is somewhere over here. Now, if you take this object to some other planet or in gravity-free space, somewhere where there is no gravity, etc., do you think the position of the center of mass will change? Do you think the position of that particular center of mass, do you think it will change? The center of mass was over here. Do you think it will change? I don't think so. It's where the mass is assumed to be concentrated. Matter. Matter does not depend on gravity or other planets. It's where actual atoms, molecules and their masses are, and where is it heavily concentrated. But there is something called as center of gravity. If you are on Earth, there is more mass here, there is more weight here. So center of gravity is where the gravitational force or the weight is concentrated. Maybe the center of gravity might come out again over here on Earth. But if you take to moon or some gravity-free environment, imagine there is no gravity, there is no weight, so this object will lose the center of gravity at all. It will not even have center of gravity because gravity only is absent. So it depends on the gravitational pull. Now, Imagine this object is very, very tall. Imagine this object is very, very huge. So the gravitational force will change as you go up. Force will become weak. We know when we are close to the surface, gravity is strong. As we go far away from Earth, gravity will become weak. So if this object is close to the Earth, here the gravitational pull will be very, very strong, very, very heavy. As we go here, it will probably become little weak. It will become little weak. Here, it will become even more weaker, right, as we go far away. So I can see the gravitational force is heavily concentrated here. So probably the center of gravity might be somewhere over here. This is where probably the center of gravity is. This is probably where the center of gravity is. So understand, center of gravity is the point where weight, or basically gravitational force, is concentrated. It depends on gravity. It depends on the gravity, and it doesn't exist. It doesn't exist in a gravitational free space. In a gravitational free space, obviously it won't even exist. Whereas this one, center of mass, is where the matter is concentrated. Matter or mass is concentrated, and important thing is it doesn't depend on gravity. It doesn't depend on gravity. Is the difference clear? In our JEE syllabus, we have center of mass, we don't have center of gravity. Yeah, we don't have center of gravity, we have only center of mass. As simple as that. Now, you might be wondering, how do I locate, sir, where the mass is being concentrated? Is there a way to find it out? The answer is simple. Let me show that to you very easily. If you have two equal masses, m and m, then the center of mass will be exactly at the midpoint. It will be exactly at the midpoint. So you can assume both the masses to be concentrated exactly at the center. You can assume both the masses to be exactly concentrated at the center. The total mass will be 2m. This is the position where the center of mass is located. But imagine one of the mass is small, another mass is huge. This is small m, this is capital M. Obviously, the center of mass will shift, be closer to the heavier mass. The total mass of this will be obviously small m plus m. This is the location of the center of mass. So center of mass is always closer to the heavier mass. If the masses are equal, it is exactly in between. And one more thing, if you join a line between the two masses, it's always in between these 2 points. It will not be outside these 2 points. It makes sense. How can the mass be assumed to be concentrated outside or somewhere off from this line? So in general, is there a formula? The answer is yes. So let's have a look at that particular formula. So the center of mass for two mass system, the location of it is given by this formula. Let me write it down. If the coordinate of this is x1 and the x coordinate of this is x2, then the center of mass's coordinate is xcm. This particular x coordinate of the center of mass is given by mass 1 x coordinate, mass 2 x coordinate upon the total mass m1 plus m2. This is for a 2-point mass system. Yes. Senthil, it is more than enough for JEE Mains. Obviously, it will be useful for your JEE Advanced as well. Okay. So this is the center of mass for two particle system. If they were y coordinates, I will write it m1 y1 plus m2 y2 upon m1 plus m2. If it is z coordinates, I will replace x with z coordinates. Now you might be wondering, sir, what if there are more masses and it's a 3-dimensional problem? What if there are more masses and it's a 3-dimensional problem? No worries. Say for example, I have mass number 1 with coordinates x1, y1, z1. Similarly, I have mass number 2 and so on and so forth. Many masses are there till the nth mass, which has x coordinate, y coordinate and z coordinate like this. Then the center of mass of this system might be somewhere over here. This is the center of mass having the coordinates xcm, ycm and zcm. Okay. So the x coordinate of the center of mass will be given by, and similarly the y coordinate of the center of mass and the z coordinate of the center of mass. Here, instead of m1 x1 plus m2 x2, it will continue for n number of terms. So m1 x1 plus m2 x2, it will continue till the last term, which is mn xn. The whole thing divided by m1 plus m2 plus m3 like that till the last mass. Similarly, this will also be m1 y1 plus m2 y2 like that till mn yn. The whole thing divided by the total mass, which is m1 plus m2 plus mn. Same thing for the z coordinate. If you want, you can also put summation. You can write it as mi zi, one and the same thing. Instead of putting plus plus so many times, you can put summation till n starting from 1 upon summation again the masses from 1 to n. So that is also okay. You can use summation symbol as well. So this is the formula for finding the coordinates of center of mass in any general 3-dimensional environment. So this is a general 3D problem now, not just 1D or 2D. It's just generic 3-dimensional problem. Okay, I think I have put it over here as well. Position of center of mass for multiple particles. Okay, the same thing. Shall we do some questions based out of this? Ready for it, everyone? Shall we do some questions based out of this? Okay, ready? Let's do. Let's start with some questions. Here it comes. First question on your screen. So imagine there is a square whose side length is A, and let's say we make this as the x-axis, this as our y-axis, this is x, this is y, this is origin, and there are some masses placed. This is m, this is 2m, this is 3m, and this is 4m. Find the coordinates of the center of mass. That is the question. Find the coordinates of the center of mass. Let's try to figure this bit out. First of all, I can figure out what are the individual coordinates of each and every mass. This mass will have the coordinate x and y both as 0. This will have x coordinate is A, the y coordinate will 0. This will have y coordinate and x coordinate both as A only. This will have x coordinate 0, y coordinate will be A. Okay, so this is A, guys. I think everything looks like 0 or A only. Anyways, so trying to find the x coordinate, xcm will be m1 x1 means m multiplied by 0 plus m2 x2, that means 2m multiplied by A, plus m3 x3, that means 3m multiplied by A, plus m4 x4, that means 4m multiplied by 0 upon the total mass m plus 2m plus 3m plus 4m. What does it come out to be? This is 0, that is also 0. 2ma plus 3ma, which will make it 5 times ma, divided by 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So divided by 10m. So it will just become A divided by 2. That is the x coordinate of the center of mass. Is that absolutely clear, everyone? That is x coordinate. Very good. Next, let's go ahead to the y coordinate of the center of mass. Similarly, ycm will be equal to, there will be many terms, m1 y1, so it will be m multiplied by 0 plus m2 y2, so 2m multiplied by 0 plus m3y3, so 3m multiplied by a, 3m multiplied by a plus this multiplied by a, only multiplied with the y coordinate, upon total mass m plus 2m plus 3m plus basically 4m. So therefore, this is 0, this is 0, 3ma plus 4ma is 7 times ma, denominator is the same thing, 10m, mm cancels, so it will just become 7a divided by 10 is the y coordinate of the center of mass. So job done. So this is how you can find out the location of the center of mass. Absolutely clear? Let's do the next question coming up on your screen. Imagine, I tell you, listen, there is a mass m and it is separated from another mass 3m like this. Can you find where the center of mass is from the smaller mass? From the smaller mass, how far is it? That is the question. All right. When you have to do such things, you can assume whatever you want as the origin and x and y axis. Because I want to measure it from the smaller mass, why not make that as the origin? Okay, why not make that as the origin and this line as our x-axis? So in that particular scenario, this mass will have the coordinates 0, 0. This mass will have the coordinates r, 0. Now you just need to find where is the center of mass. Obviously the center of mass will be somewhere, let's say here. The x coordinate of the center of mass will be m1 x1, so m multiplied by 0 plus m2 x2, so 3m multiplied by r, whole thing divided by this mass plus this mass, which will make it nothing but 3mr divided by 4m, which is basically 3 by 4 times of r. That is your x coordinate of the center of mass, which is also the distance, from here, from the smaller mass. So the distance from the smaller mass is 3r by 4. Very straightforward. Simple? Clearo? Can we go ahead? Yep. Yep. Very good. Nikhil, 6 minutes behind, no issues. You can catch up very soon. Don't worry. In case you are joining in late, continue from the beginning. Maybe you can watch it little fast. Anything that you want to skip, you can skip and catch up. Senthil Raju, yes, you can get without coaching into NITs and IITs. Who told you that you need coaching? Obviously, without coaching, you can get it. But you have to maintain the discipline. You need to maintain that level of focus. You need to get your doubts clear. You need to practice that many questions. You need to practice it in the right way without taking a drop. Also, you need to be aware of the competition. So if you can manage everything, there is no need. Who says so? The problem is, most of us, forget normal students, even I wouldn't be able to do it without coaching. Okay, so there is nothing like you should be proud that I'm doing without coaching. It's a very good thing. But at the same time, there is nothing wrong in taking coaching. Okay, so I'm telling you, frankly, I'm pretty sure I and many teachers without coaching wouldn't be teachers, wouldn't be able to get into the top-notch colleges. All right, now this problem is done. Moving on to the next question. This is another interesting question coming up on your screen. Let's see if you can figure it out. What happens now is that imagine there is a mass here, let's say m, and there is another mass here, let's say 5m. Okay, the center of mass will be somewhere obviously here. Now what happens is this particular mass is at rest, whereas this mass is moved along the y-axis. Is moved along the y-axis, along y-axis. That is the motion of other particle. Question is, the center of mass motion will be how? How will that center of mass move? First option, it will go straight line. Second option, it will go here. Third option, it will go here. 1, 2 or 3. What do you suggest? Let's see which one do you think it will do. Will it go slightly towards the left, slightly towards the right, or exactly straight? Infant Akhil is dropping worth. Well, it depends what is worth for you. For me, a Rolex watch might not be worth. People go mad about some Rolex watch or maybe some crazy gaming laptop. For me, I might be like, I don't like gaming, I don't like those fancy watches. So it is not worth for me. But for some person, it's worth it. And they might spend thousands of rupees on buying that thing or a gaming console. Are they wrong? No. Definitely. They love gaming. They will buy a nice gaming console. They love watches. They'll buy it. If they can afford it, definitely they should. But if some poor person says, I like gaming console and I want to buy Rolex watches, then it's not worth it for him. Even though I might have a lot of money and I'm not buying it because it's a conscious choice. I don't want it. Maybe I'm happy. So same way, when you are deciding whether dropping is worth or not, maybe you can afford it, maybe you can not afford it. When I say you can afford it, means, fine, you don't have many responsibilities, or you feel that it's not just monetarily, it's also time-wise. Yes, I can give one more year of my time. I don't feel that it will be a waste. It's okay. And, you consider IIT or top colleges to be the best colleges in the country. You want to get in there. I want to do research. I want to be in that crowd. I want to be in the entrepreneurship club, whatever. Then it is definitely worth it. But if you feel, okay, I want to do this, but the medium, the manner, path may not be through IIT, or, I don't think I have that money, or maybe I don't think I can afford one more year. I want to start earning. Then it is definitely not worth it. So it's you who decides. That's what I would say. Is that clear, infant? Okay. So Harborine saying option number 3. What about others? What do you think will the center of mass do? Will it take path 1, path 2, or path 3? I have a feeling it will not take path 2 or path 3. It will probably take path 1. And I'll tell you why. When 5m moves, the x coordinate of that 5m is never changing. It is basically a constant. Same thing, the x coordinate of m is also a constant, which means xcm, which was m into xm plus 5m into x coordinate of that 5m mass upon m plus 5m. None of this changed. So this whole thing was a constant. But the only thing that changed was the y coordinate of the center of mass will definitely change. So if only the y coordinate changes, that means the center of mass should go like this. Yes, in a straight line parallel to the y-axis. Definitely. Is that clear, everyone? Understood? So the path taken by it is path number 1. Great. Awesome. Now, all these times, whenever we have found center of mass, either there were 2 masses, 3, 4 masses, 2D, 3D, whatever. Okay, we have found this out. These kind of systems are called particular systems or discrete mass systems. But you have objects like this, which are continuous bodies. Like for example, this pen. It's a continuous body. It is not made of 10 or 5 masses. There are infinitely many particles. Yes, they are countably large, but it's like continuous. So many things are there. You think of it like continuous, especially for your naked eye. So when you have so many masses and you cannot really count so easily, it's called as a continuous body, like your cup or table or spoon, right? Or the wall or a stone or a brick or you yourself, okay? Or a solid sphere, a solid cube, all right? All these are examples of continuous bodies. Now, in order to find the center of mass of such continuous bodies, one is, you see if it is symmetric. If it is a symmetric body, then you don't have to break your head with any formulas. The answer will be, the center of mass will be at the geometrical center. Meaning, if it's a ring, If it's like a ring, it will be at the center of the ring. If it's a disc, it will be at the center of the disc. If it's a square plate, it will be at the center of that square plate. Makes sense? For practical purposes, this book is like your rectangular plate. So the center of mass should be exactly in between. So if I hold it probably somewhere over here carefully, you can see I can balance this book just with one thumb or one finger. Can you see that? I'm just able to balance it because I'm holding it exactly at the center of mass. Isn't that crazy? So that's where the center of mass definitely lies. Right. Same way, if it's a cube, it will be exactly at the geometrical center inside that cube. It's not on the surface, it's at the body center. Cylinder will be on the axis at the midpoint. If you take the height, cut it by half, and on the axis inside that solid cylinder. If you take a sphere, it will be exactly inside that sphere at that center of the sphere. So for continuous uniform bodies, the center of mass will be at the geometrical center. Does that make sense to all of you? Does that make sense? Rotation will come later on. Yep, correct. There is one interesting thing though, which you might have realized over here. Do you see the center of mass is not on the body? So tell me one thing, is it necessary center of mass should lie on the body? Can it be outside the body? The answer is yes. Don't think center of mass will always be within that body, like here, here or here. It can lie even outside the body. Imagine somebody takes a horseshoe magnet. Center of mass might be here, which is entirely outside that magnet. Okay. So guys, center of mass can lie inside, on or even outside the body. In fact, there are few things which you should know. Center of mass can lie within or outside the body. Very important. Also, the choice of coordinate system. Remember, we are choosing coordinate system. The choice of coordinate system can affect the coordinate of the center of mass, but not its actual position. What do I mean by this? But not its actual position. Say for example, in this particular scenario, if I didn't choose this as the origin, if I choose this as the origin, then what will happen? The coordinate might come out to be negative. But does that mean the center of mass has shifted the location? No. The center of mass is there only where it is supposed to be. It's just that instead of keeping the origin here, I kept the origin here, so the coordinates have changed. So choosing different coordinates might change the coordinates of center of mass, but it won't affect the actual location where the center of mass is present. Even in this case, my origin was here, center of mass came out to be here. If I choose the origin to be somewhere here, center of mass will still be here. The coordinates, final values will definitely change. Make sense, everyone? Hi, Pranay. All right. So that is another important thing which you should know. Now, you might be wondering, sir, what if it is not a symmetrical body? Like for example, say this particular charger. 100% it is not so symmetrical. It is not easy to find the center of mass. So what will you do? How many masses will you count? You can't count the number of masses in it. Hence, this particular formula which we just saw over here, which is summation of mass into Z upon total mass, or mass into Y upon total mass, or this one. There will be infinitely many terms, and these masses will be teeny mini masses. This M1, M2, M3 will be like small masses, and whenever a mass is small, you call it as dm. dm, delta m, where delta tends to 0. So you divide that body into infinitely many masses. Each mass is dm, multiply it with the respective coordinate. Summation will be now replaced by integration, summation, similar things, and divide it with the total mass. That's what the formula will come down to. So hence, whenever you have continuous body systems like this, This is a continuous body system. Then basically the x coordinate of the center of mass, for example, will be integration coordinate multiplied by that small mass divided by integration dm. Same thing, the y coordinate will also be given by, here you will have integral y dm upon integration of dm. Similarly, the z coordinate of the center of mass will be integral z dm divided by the total mass. So that's what the formula will modify to, just integration. You might be wondering what will be the limits of integration? Well, the limits of integration will depend from problem to problem. That's all. So let's take an example to understand this. Let's take an example to understand this. And before we go to understanding process, you should know how to choose the elements. You should know how to choose basically elements. If it is a linear body, if you take a small mass over here, that will be dm. And for linear bodies, you have a term called as linear mass density. Usually, the symbol for that is lambda. Linear mass density means it is how much mass is there per unit length. So, if this small mass along that length is having a width of dx, then lambda in this case will be dm by dx, or dm will be lambda into dx. Choosing element should be something of priority, and you should know how to choose an element. So for linear long objects, this is how linear mass density is defined, and this is how you will choose the masses. Long objects like rods. Similarly, if you have some sheet over here, okay, it's a lamina or basically a sheet. You can divide it into small parts, and each part will be a two-dimensional thing. It will have dm mass and it will have an area of dA. Now what you get is areal mass density. Usually the symbol for that is sigma, and it is nothing but how much mass is there per unit area. Therefore, that particular sigma will be the mass of that particular part upon that area, which means dm will be sigma into dA, will be nothing but sigma into dA. Lastly, just say you have some three-dimensional object like a stone, some sphere, anything. Then you choose a small mass somewhere over here. That mass will be dm. The volume that it occupies is dv. Now you have your regular density, or basically volume mass density, which is your regular density, and that regular density symbol is rho. It is nothing but mass per unit volume. So this density will be the mass, which is dm upon dv. Therefore, that dm will be rho into dv. Is this clear? So depending on what type of object is it, if it's a square plate, rectangular sheet, circular disc, or triangular sheet, then you will use this. If it's a solid sphere or solid cylinder kind of a thing, or cuboid, then you will be looking at volume mass density. If it's a wire, arc, straight line, rod, string, then you will be using at linear mass density. Okay, so something which you should be aware of. Lambda, sigma, and rho. Haven't you seen these terms in 12th standard, or if you are a 11th student, you will see it in 12th for linear charge density, areal charge density, and volume charge density. In the chapter of electrostatics, lambda, sigma, and rho also come in. Is that right? Yeah. Pranay, gravitation will be done after rotational motion, not before that, because we need the concept of angular momentum for it. So we are waiting for that. Okay. Otherwise, we could have done it. no harm. Okay, so let's take an example of how we can find the center of mass of a straight rod. So let's just take a random straight rod like this, whose length is L, and they tell you, listen, the lambda is given by lambda naught x by L. Meaning, here, if you substitute the x coordinate as 0, there is no mass. As you go here, the mass density increases. Maybe the filling has changed. The alloy is changing its composition. Here it is light, here it becomes heavy, heavy and heaviest. So they have told you, listen, this is the x coordinate, this is the origin, this is your y-axis. So lambda is given to be this. Question is, find the location of the center of mass. Where is the center of mass? That is what they have asked. Let's try to do this problem. Because it's a continuous body, many particles are there, obviously we have to shift to this. You'll be like, okay sir, integration of x is x square by 2. Wrong. I can't do that because I can't integrate x with dm. So that's the first challenging part. Either convert x as m or dm as a dx. I can't integrate something else with respect to something else. So after that only I can figure out the limits. Because it's a slender object, I should be worried about linear mass density. So I will choose some random mass somewhere over here, whose x coordinate is x, whose width is basically dx, and the mass is nothing but dm. So as per our formula, x coordinate of the center of mass will be integration x dm, the whole thing divided by integration dm. Do I know dm? Well, definitely I do, because lambda I know is nothing but dm by dx, and lambda itself is lambda naught x divided by L. This is dm by dx. Therefore, what do I get? dm is equal to, shift this dx on the top, lambda naught by L x dx. Converting dm into dx, that was our primary objective, without which we cannot proceed. So I will substitute dm. Instead of dm, I'll put all those things. So what will I get? I will get integration of x is there. Instead of dm, I will put lambda naught by L into x dx. Same thing below also, integration of lambda naught by L x and dx. Now you might be wondering, sir, since we have converted it, can't we put the limits? Of course we can put the limits. What should the limits be? Think. I will take all the masses. If I don't, I'm not finding the complete center of mass. So I should start off with the first mass here and I should reach here. So when I start here, the x coordinate will be 0. When I reach here, the x coordinate will be the length of the rod. So that's why the limits of the integration will be 0 to L. But one more crazy thing happens here, and I hope you see that. Lambda naught is a constant, L is a constant. These both come outside the integration and they end up cancelling out with each other. So cool. They just ended up cancelling out with each other. So now what am I left with? X into x is basically x square dx, and below I have just x dx, limits 0 to L, 0 to L. Therefore, x center of mass will be, x square's integration is x cube divided by 3. Limits have to be put 0 to L in the next step. Here it will be x square by 2. Again limits 0 to L. When I substitute the limits, it will become L cube divided by 3 divided by L square divided by 2. L square divided by 2. Is that right, everyone? Yep. Definitely, Senthil Raju, you will. Please follow regularly. Don't miss any classes. L square will cancel. 2 will go on the top. L will remain on the top. This 3 will remain below. So that's the actual coordinate of the center of mass. 2/3 of the length means the center of mass is somewhere over here. The center of mass is somewhere over here on the 2/3 part. Makes sense because this side was light, this side was heavy. So center of mass should be on the heavier side. It can't be on the lighter side. Yeah. Rotation is very important. Gravitation, every time a question will definitely come. So it's like a sure shot topic. So we have found the location of the center of mass. So this is how you can solve for any problem. Whenever continuous bodies come, you can divide it into small segments and integrate it to find the location of center of mass. Now the best part is that we have done this already for many of the objects. Like for example, say solid cone and hollow cone. If you have a solid cone, if you want to find the center of mass, I feel you will divide it into small segments like discs. Imagine a big disc, over that a slightly smaller disc, slightly smaller one, slightly smaller, till it becomes a point. So you divide it into many discs like you cut onions or potatoes. And you know the size of the disc keeps on becoming smaller, and each of those small thin wafer like disc is going to be a dm mass, and you combine all of them together, you find the center of mass is at a distance of the total height by 4 from the base of the cone. It does not depend on the radius, that's the funny part. Okay, it does not depend on the radius, it only depends on the height. It is h by 4. If you take a hollow cone is like your birthday cap, birthday hat. If you have seen that emoji where if you type in party, one person is blowing something and one birthday cap comes, so it's hollow cone. Or if you have eaten ice cream, imagine the ice cream is taken out, only that waffle cone is there. So that is a hollow cone, the base is not there, then the center of mass is at h by 3. Now if you ever get confused, sir, when is it h by 4 or h by 3? Simple trick. Solid means this is completely filled, right? Imagine ice cream filled inside this. So more mass is there below, so that's why the center of mass will be more below. So h by 4 will be smaller, h by 3 is slightly larger because it's empty, so center of mass will be slightly on the upper side towards the vertex. Here it will be more towards the base. So the smaller one is h by 4, bigger one is h by 3. Is it simple to understand now? If you ever get confused, that's how you will remove your confusion. Clear? Give me a thumbs up, guys. Come on, keep chatting, keep saying yes, no, yes sir, got it, h by 4, h by 3, type it out, it will go enter your head. Cool? Very nice. Then the next geometry that you should remember is hollow sphere and solid sphere. Again, between hollow and solid, hollow means like a bowl, solid means a bowl full of some ice or some grains, or you take a solid sphere and cut it into 2 halves. Solid sphere, the mass will be down close to the base. Hollow, it will be slightly on the top. For hollow, it is exactly at midpoint of the radius, which is r by 2. Yes, for hollow sphere, it is at r by 2. For solid, it is slightly below. It is at 3r by 8. 3 by 8 is slightly less than half. So it is slightly lower, closer to the base of the solid sphere. That's how you can remember. Sir, I remembered r by 2 and 3r by 8. Don't be confused. The smaller one will be closer to the base, and that's solid sphere. Great. So this is done, and hollow cone and solid cone is done. Now the next geometries, forget the disc in general, look at a sector. This is a sector like a pizza. Imagine you have ordered a pizza from Domino's or Pizza Hut. So there are many slices, these are sectors. So complete pizza is there. Complete pizza is there. You take a small slice of it. That is a sector. So actually I should put over here, not a disc. This should have been sector. This is a sector. Versus an arc. Now when I say arc, it means only this much is there. Only this much is there. Somebody ate all the cheese and the toppings. What they gave you is a crust. This means all the things, toppings, crust, everything is there. How many of you like to eat the crust? How many of you like to eat the fillings? How many of you like both? Accordingly, now you can visualize what is the meaning of sector versus the arc. If it's a sector, the center of mass will be somewhere here. From the center, which is the geometrical center, this distance is basically nothing but, actually forget this formula, I will tell you it in the modified form. Two by 3 or sine theta by 2 by theta by 2. So actually that 2 goes on the top, 2 multiplies as 4, so 4r by 3 sine theta by 2. If you are wondering what theta is this complete angle. Theta is basically that complete angle. Okay, so this entire angle is basically theta. So theta by 2 is the semi angle, half angle. Got it? So this is where the center of mass is for a sector. Now, if you are wondering, sir, what is the application of this? This formula for a disk, semicircular disk, can be obtained from here only. Think about it. In this particular formula, somebody substitutes theta as pi because this is theta. Think about it. The theta will be basically pi radians. Sine of pi by 2, which is sine of 90, it will become 1. This is pi, this is 2. 2 multiplies with this 2, it will become 4r by 3. This was 1. So it will become 4r by 3 pi. Exactly. It should be basically 4r by 3 pi. That is what the answer is. So if you substitute theta as pi, you will get it. If it's a quarter disk, you will substitute theta as pi by 2 accordingly. So that is the importance of this. It's a more general formula. If you remember only for this guy, then if some other problem comes, you will be stuck. So that's why more than this, I suggest you to remember this. So this is more important as compared to this. Is that clear? Obviously, these things are important. You cannot afford to forget it. You can't say that, sir, are these important or no? You never know which question might come. You never know which question might come. Now, if you look at the arc formula, it is very much similar. It is very much similar. Let me just write it down over here. It is basically r sine theta by 2 by theta by 2. If you notice the difference, here there was 2r by 3. This was sine theta by 2 by theta by 2. Here that 2 by 3 factor is not there. It's just r into sine theta by 2 by theta by 2. So then the center of mass from this point to here will be at this particular distance. From the center to this is the distance. So if you take a semicircular ring, that means the theta will be nothing but pi. Theta will be nothing but pi. So substitute pi over here and see what do you get. Sine 90 by 2. Sorry, sine pi by 2, which is sine 90, which is 1. So numerator became 1. This is pi, this is 2. 2 goes on the top, 2r by pi. Exactly, 2r by pi. So this is a special case formula. This is a more general formula. So it's always better to remember this as compared to this. Rod is very simple. Obviously, it will be at the center only, L by 2. It's a symmetric diagram. Yeah. This is for both class 11th and 12th. This is a class 11th standard topic. So if you are a 11th standard student, you should be attending this class. If you are a dropper and 12th, then though you don't have option, you have to. Yeah? Yeah. Yes, Madhavraj, in the pro batches, you can ask doubts to your teachers. Plus, we have additional class teacher. Plus, if there is a technical difficulty, we have something called as the proctor who will assist you with the class, who is like a helper. In the offline coaching, you might have seen somebody to help assist you, like somebody sitting outside. So we have somebody to assist you like that also, non-academically, and academically, you have a person exclusive for your doubts. And sometimes if you feel that this doubt is even more important, you can definitely connect with your teacher. The batch sizes are not very huge. The batch sizes are kept decent so that teachers know all the students and students have personal interaction also. That's how it goes. Good evening, Usha. Is that right, everyone? So try to write this down at least 10 times. It won't enter your head otherwise. You might be thinking, sir, I know that. Sir, it is there in my head. Trust me, tomorrow morning, forget tomorrow morning. After dinner only, you will not remember. So write it down 4-5 times now. then before sleeping, tomorrow, then after 5-6 days, and then maybe after 1 month, and then maybe after 3 months. Then it will enter your head. That is how you revise. Revision does not mean you revise once and that's it. No, you have to keep looking through it. And that's why I say use flashcards. I don't know how many of you have been using the flashcards, which I showed it to you before. The flashcards look like this. These are like pocket size cards, and you can pick out any chapter which you want. Let's say for example like this, and you get a flashcard over here. All the formulas are written down, and when the job is done, you just put it over here. You want to revise something in school today or while traveling, just carry that particular flashcards. It's very nice. Use it. I have made a video on how to get your JEE flashcards delivered at your home. It's there on the home page, right? Fluids, there is a lot of time, bacha. Murugan, you already done it. Sorry, Muruga, we already done it. Very good, great. Now that we are done with this, let's do some questions based on this. Say for example, okay, so the question is find the location of the center of mass. First time it's an arc, second time basically it's a sector, quarter of a circle. Let's try to do this. Because it's a quarter of a circle, it's an arc, I know how to use the arc formula. So let's do that. Let's use the arc formula. But I know that the center of mass will lie on the angle bisector. Do not forget that. So the angle bisector will be like this, and the center of mass might lie somewhere over here. And this is the distance which I can find out. Now this distance where the center of mass will be located, by the way, let's not forget this angle is pi by 2. Using the arc formula, the distance is given by radius sine theta by 2 by theta by 2. Radius is r, theta is pi by 2 divided by pi by 2 by 2. So pi by 2 by 2 is pi by 4. 4 goes on the top, 4r by pi comes here. This will become sine of pi by 4, which is 45 degrees. So it will become 4r by pi. 45 degrees sine is 1 by root 2. So pi root 2. So that is the distance from the origin where the center of mass is located. But let's say by chance you are asked, find out the x coordinate and find out the y coordinate of the center of mass. Find out the y coordinate as well as the x coordinate of the center of mass. What will you do? Because these two coordinates will be equal, because it will be 45 degrees. One thing is clear, x cm will be y cm, because this is 45, this is 45 degrees. So it will be, this distance is cos 45 component, d cos or sine 45. But wait a minute, d value I already figured it out. It was 4r by pi root 2. Cos 45 is nothing but 1 by root 2. Root 2 into root 2, 2. 4 and 2 cancels, it will become 2r by pi. So hence, the center of mass coordinates are 2r by pi, comma 2r by pi. That is the answer. Is that right, everyone? Got it? How we solved the question? Cool. So always The distance is from the center and it will be on the angle bisector like you have seen in all these questions. Where did it go? Even in this question, it is on the angle bisector of the center, or even here, angle bisector of that arc. So now, if you talk about this center of mass, I think you should be able to do it. Okay, very similar logic, and the center of mass will be at some distance over here, and you need to find out this distance. And then you can also find the x coordinate as well as the y coordinate. So this will be your x coordinate, this will be your y coordinate, and obviously x coordinate will be the y coordinate, which will be the distance cos 45 just like before, and you can find that out. Can you do this as homework and post it in the comments? Homework. Okay, the answer has to be in the comment section. Answer in the comment section. Done? After the session is over. Why is d cos 45 the coordinates? Because if you see that particular triangle, this will be d, this will be x, this will be y, this is 90 degree, this is x, this is y. How much will this be? This will be 45 degrees. So base is d cos 45, cos 45 is adjacent by hypotenuse. That's the reason for that. Make sense? Now, clear, Nikhil? Sean, you're little late, definitely. Try to start from beginning. Starting from here might make you feel out of place in case you have no idea about this chapter. Okay, so I'm pretty sure you will be able to do this. Just be careful, this is a sector, so make sure you use the sector formula for that distance. Yeah, remember that 2 by 3 r sine theta by 2 by theta by 2. Okay, so try it out later on. Now comes the next thing. Fine. Given the formula, I can easily locate the center of mass. All these formulas I will by heart it, no issues. But sometimes you might have a combined geometry. For example, imagine somebody put an ice cream scoop like this on a cone. Such a beautiful ice cream cone I have. Or maybe you have a solid cube in which somebody has made a hole and taken away something. Okay, somebody has made a hole and taken out something, maybe like a cylindrical hole. Or maybe you have a sheet which is joined to a semicircular disc. This is your cutout. Or somebody has taken a triangular sheet and punched a hole in it. Okay, this part is solid. Somebody has punched a hole in it. These kind of systems are basically composite bodies where either you join two geometries or you subtract two geometries and you get the desired figure. If you notice, this one and this one are found by adding two or more geometries. This or this is obtained by subtracting two geometries. Such things are basically called as composite bodies. What are they called? Composite bodies. Now, in case of such systems, what you do is, observe carefully. It's not at all difficult. Let me tell you what to do. Say you have some system joined to another system. Let's say you want to find the combined center of mass, and I know this guy's center of mass is here. This is center of mass of object 1. This guy's center of mass is here, center of mass of object 2. The whole body as such, center of mass is here. This was broken down into two parts. The coordinates of the center of mass is given by You treat this body as a point mass over here. So it will be having some mass m1. The coordinates will be x1. This mass is m2. So m2 x2 upon this whole thing will have some mass. That will be obviously m1 plus m2. So this will be m1 plus m2 over here. That's it. That's how you find the x coordinate. Same thing you can do with the y coordinate as well as the z coordinate if asked. This is just like before. This is just like before. Just that replace x with y and z with, x with y here and x with z in this case. It's very identical. Just treat individual bodies like point mass. Very straightforward. But imagine now there is a particular body. Let's do it like this. There is some kind of object which is taken out. This is basically equal to this whole thing, assuming the entire thing was there, minus from this you have taken out a small thing over here. You have taken out a small thing over here. So let's say that this has a center of mass somewhere over here. Center of mass of the first body, this is mass m1. This is center of mass of the second body having mass m2. The combined center of mass could be probably here, center of mass of the complete body. This mass will be m1 minus m2. So in such a case, the x coordinate of the center of mass will be given by, you take mass number 1, coordinate of this guy, mass number 2, coordinate of the scooped out part, subtract this and divide it by the total mass. Now it will be nothing but m1 minus m2. The same logic applies for even y as well as z coordinate. Just replace x with y here and replace x with z over here. That's it. That's the formula. Okay, so this is for bodies with cavity. For bodies with cavity, this is for bodies with cavity, and this is for composite bodies. Composite bodies. That means you are adding 2 or more bodies together. Is this clear, everyone? Both these things, concepts. Shall we do questions now? Yeah, it's like the moment of inertia cutting. May I ask teachers on Instagram? No, I'm not sure, Madhavraj. That depends from teacher to teacher, right? So don't expect to ask teachers doubts on Instagram. Really doubtful. Okay, great. So let's do some questions. Maybe we have a question over here only. Yep, let's see how do we do this. A composite body is made by 2 or more bodies, finding the center of mass of the body of a uniform disk of radius r and uniform square plate of side 2r, mass per unit area is the same. You have to find where the center of mass will lie. Very interesting question. Tell me, won't you break it down into a circle and a square? Where will be the center of mass of this guy? Obviously at this center. Okay. What is the coordinate of this point? This distance will be r, y coordinate will be 0. So I can just say it is r, 0. Cool. The next object is a square. Center of mass of a square will be here. This is r, this is r. This will be also r because side is 2r. So half the side will be r. So r plus r will make it from here to here 3r. So it will be 3r, 0. So mass of the circle is m1, mass of the square is m2. So naturally the center of mass will lie somewhere over here. So this is where your center of mass will lie, somewhere in between. I don't know where, I have to exactly find it out. Now if you apply the formula also, x coordinate of the center of mass will be nothing but m1 into x1 plus m2 into x2 divided by m1 plus m2. The problem is I know x1 and I know x2, but I don't know m1 and m2. I don't know that. You will be like, okay sir, what do I do? Read the question. Isn't it like a disc and a square plate? Means it's a lamina, it's like a sheet, it's a 2D diagram. And whenever we have two-dimensional diagrams or sheets, the concept which you should worry or consider is mass per unit area, which is sigma. Mass per unit area. That is the concept that will come into play for two-dimensional objects. If it was solid, square and sphere, then it will be mass per unit volume. Both of them have same mass per unit area. That means basically we are talking about sigma over here. So sigma is mass of the circle upon area of the circle, which is pi r square. It is also mass of the square upon area of the square. Side is basically 2r, so 2r square. So how much will be mass number 1? It will be sigma pi r square. How much will mass number 2 be? Bring this guy here. It will be sigma 2 square is 4 r square. Perfect. I got m1 and m2, so I'm just going to substitute that. Mass 1 is sigma pi r square. Mass number 2 is sigma 4 r square. The whole thing divided by sigma pi r square plus sigma 4 r square. Of course, we have to substitute the coordinates. x1, first coordinate is basically r, plus x2, the second coordinate is basically 3r. Now we will be able to solve it. But before going ahead, a lot of things are just going to cancel out. Sigma, 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 sigma. R square, R square, R square, R square. Perfect. So I am just left out with pi r plus 4 into 3, 12r divided by pi plus 4. Therefore, the x coordinate of the center of mass, take out r common, pi plus 12 divided by pi plus 4. That is the answer. Let's figure it out. Yes, pi plus 12 by pi plus 4 into r. That is the x coordinate. Y coordinate is obviously 0. Did you now get it? How to solve it for combined bodies, composite bodies, added objects? You might need mass per unit area. You might need mass per unit volume. That's it. If it was a solid sphere and this was a cube, then this will be rho, this will be volume and volume. Volume of a sphere is 4 by 3 pi r cube. Volume of a cube is side cube. That's the only difference in the entire solution. Otherwise, everything else will be same. Got it? Hi, good evening, Geeta. Perfecto, Nikhil, Harborine. Great. Let's go to the next type of question now. Let's go to the next type of question. Yeah, where we'll have truncated bodies, basically bodies with cavity. Bodies with cavity, basically that is what we have seen over here. Something is truncated. Truncated means removed or cavity is there. So let's try to solve this kind of question. Alright. Now over here, like I said before, you have to see which mass was removed from which mass. So think about it like this in this particular scenario. So you had a big mass, from that you have subtracted this mass. So this mass was there, from that you have removed this mass. Don't change the coordinate system or else you will get a completely wrong answer. For that big circle, the center of mass was here and the coordinates will be 0, comma 0. For that scooped out circle, the center of mass will be here. Disk equal to radius of half the original disk. Radius of the original disk is r. So basically, this whole thing, if it was r, therefore the coordinates will be r by 2 comma 0. This will have mass number 1, this will have mass number 1, this will have mass number 2. That's it. Now the combined center of mass will be somewhere over here. This is where the center of mass will be, because if you take out something from here, if it's gone, the concentration will shift towards the left side. Okay. Now it's a disk again. If it's a disk, it's a planar object. So will you use lambda, will you use sigma, or will you use rho? Quickly think and tell me. Will you use lambda, will you use sigma, or will you use rho? What are these lambda, sigma and rho? If you have forgotten, let's get back. Lambda is mass per unit length, this is per unit area, this is per unit volume. It's a two-dimensional thing, sheet-like thing, so it is always sigma. So sigma plays a role. If it was solid sphere, obviously it will be rho. Okay, perfect. So I will need the concept of sigma over here. So sigma will be equal to this mass upon this area. Think about it. So sigma will be mass number 1 by the total area of the big thing, which is basically pi r square, which will also be the mass of this guy, which is m2, upon this area, which is pi r by 2 square. So if you look at m1, shift these guys over here. So m1 will be sigma pi r square. If you ask me how much m2 will be, shift these people over here. So it will be sigma pi r square, 2 square will be 4. That is what m2 will be. So m1, m2 is done. I think now we can go ahead. Yes, Joseph. Yes, Nikhil. Yes, Harborine. It is sigma. Correct. Yeah. Sir, JEE Mains 2024 refocus series enough for JEE Mains 25. What is this refocus series, Janvi? Which channel is this? Okay. Now let's solve the problem. X coordinate of the center of mass, because I know the Y coordinate will not be there, only it will lie on the X axis. It's symmetrical. So it has to lie somewhere on this line. So it will be nothing but m1 x1 minus m2 x2 whole thing divided by m1 minus m2. What is mass number 1? Check it out from here. It is sigma pi r square. What is mass number 2? It is sigma pi r square by 4. Whole thing divided by sigma pi r square minus sigma pi r square by 4. Now substitute the coordinates. The first coordinate is basically big fat 0. The second coordinate is nothing but r by 2. Again, a lot of things just get cancelled out. Like for example, sigma, 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 sigma. Pi, 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 by. R square, R square, R square, R square. This is just 0. So just forget this. So I am just left out with negative r by 4 into 2 is 8. Whole thing divided by 1 minus 1 by 4, which is negative r by 8 divided by 1 minus 1 by 4 is 3 by 4. 4 goes with 8 2 times. So it will be minus r by 3 multiplied by 2, which is minus r by 6. That's your x coordinate of the center of mass, which is exactly the answer what we were expecting. Don't get scared because you are getting a negative sign. You should be scared if you don't get a negative sign, because center of mass is on the negative side of the x-axis, so has to come out to be negative. So this just verifies that whatever we have done might be right. Yeah. Okay. Great, great. Oh, the 2-week challenge series. Yep. See, Janvi, please follow the ROAR series as a whole. We keep giving you challenges because sometimes students lose focus or lose motivation or probably students, are not on the right track. So we give up a challenge for all of you so that you can get back on track. But eventually you have to complete the ROAR series. The ROAR series, the older series also you can do, Pathfinder, Nurture, which is there on this channel. Even if you watch that or this, preferably watch ROAR, okay, because it's new, fresh, you are in the live class. I would say that yes, you can clear JEE Mains 2025. There is no doubt in that. Is that okay? If you are late, start now. If you don't start now, tomorrow you will be even more late. It's like something you feel that, sir, I should have done this today only. I should have bought this today only, sir. Sir, the price was very low. Some iPhone. Sir, shit, I should have bought it that time only, sir. Now the price has slightly increased. Sir, the price has increased even more now. So you will keep on missing out on it. And then you will be like, sir, now new model only came out. Basically, then you have to prepare for next year by taking a drop. So that same thing is applicable. Start now. You might be late, but better late than never, and preparing for the next year. Cool? Start today with small things. You'd have no idea, even by starting with vectors chapter or units and dimensions, within just even the September end month, you would have completed at least 3 chapters maybe. And then by October end, you would have completed maybe 8 to 10 chapters. We have just 30 chapters in physics. Same thing approximately this is. And similarly, some 30 chapters here and totally 90 chapters are there. Within a month's time, by October end, for all you know, you would have done some 20 to 30 chapters. You're like, sir, it is still not enough. I have 90 chapters to go. Who is asking you to do 90 chapters? Do 60 chapters by December end. Still you will get more than 97 percentile, 98 percentile. Yes, that's how it is. You have to just plan it smartly. Right? Yep. Nikhil, it's like 2 different mass elements. Yes, it's like 2 different mass elements. Correct. So now we are done with different kinds of composite bodies. So whether you truncate it or you add it, we have done those kind of questions. Correct. Now, yeah, this is done. This is also done. Okay. Oh, there are some interesting applications of center of mass which I want to tell you right over here. One of the very interesting application of center of mass is, imagine you have a body like this of mass m, and let's say this is your reference line. The center of mass of that body is particularly here, and I know that it is at a height h from this reference line. Then the gravitational potential energy of the entire body is same as the gravitational potential energy of just the point mass, which is center of mass, where the mass m is assumed to be concentrated and it is at height h. So whenever you want to find the gravitational potential energy, assume the body to be a point mass and then your job is done. It's that simple. You will be like, sir, where do I use this in any kind of question? Let me tell you over here. This is a very interesting question. So say there is a very, very smooth table. There is a very, very smooth table like this. And what happens is, there is a snake. There is a snake or some chain or some rope or some belt which is hanging with 1/3 part hanging here, 2/3 over here. Okay, so let's say this is our snake like this. Very nice snake. Okay, it's hanging. It's a slippery snake, smooth table. It's hanging 1/3 here, 1/3 here. You are holding its tail. You leave it. This mass will experience its own weight. So it will start falling down. Obviously, this part also has to accelerate. Then all the entire chain or the rope or the snake will start going like this, and eventually you will see the entire snake, that entire snake will be over here like this. By the time it reaches here, obviously it has some velocity. The question is, how much is this velocity? Okay, that's the question. Very beautiful question. Sometimes the question is reversed. They say that a chain is completely hanging and I want to bring it on the table like this. So how much work needs to be done? The concept is the same for these kind of questions. Whether it is falling and you have to find the speed, or you have to pull it up and find the work. The concept is of energy conservation. See, you cannot find the acceleration and find the velocity. Why? Because it is a lengthy process. Why is it lengthy process? Because acceleration is not going to be constant. Why is it not going to be constant? Because the mass here will keep changing. If the mass which is pulling it down keeps changing, the weight keeps changing, the force keeps changing, the acceleration keeps changing. So you can't use kinematic equations. It will unnecessarily involve calculus and complicate the scenario. So avoid going by that method of forces. Is this point clear? Why we are not finding it through kinematics? Because it is not even applicable, nor can I find the acceleration so easily. It involves variable acceleration. So I am not going through that particular part. Is that right, everyone? Okay. Now, if I have to go through some other way, that means energy conservation. Let's see, how do we apply energy conservation? Can you tell me, or can you say which energy got converted into which energy in this process? Does it have spring energy, elastic energy? No. Does it have kinetic energy here? No. Does it have gravitational energy? Yes. So it loses it and it converts into kinetic energy. Oh, so that's the concept. And to find gravitational energy, I just told you, look at where the center of mass is, your job is done. Let's take a good reference line. Without that, you will unnecessarily face a lot of trouble. So how about choosing this line as my zero potential energy line? So anything on that line has zero potential energy. Okay, perfect. Now if you look over, first let's look over here. This body right now has its own center of mass located over here. The mass is m. This is where the center of mass is. The total length was L. So this will be how much? L by 2. So what is the final potential energy, guys? It's down, so negative. Mass m, g, height is basically L by 2. That is the final energy just when it is falling down with some speed. Look over here. This part, center of mass is here, only the upper part, which is on the zero energy line. So that will have 0 joules of energy. 0 joules of energy, which is on the top. The one which is on the top. This part has a center of mass here. And what distance is it at from this line? Can you tell me the distance where this mass is from this line? Quickly think and tell me. Where do you think it is? Yep. Partial drop is possible, but I would not suggest you to do so for JEE. It's not advisable. Okay? Because if you have taken a partial drop, that means most likely the college you are not at all happy with. Chumma taking it, you will be wasting money. Plus, you will not be so serious about JEE. And JEE mains is, trust me, tough. It's not, rather than tough, it's competitive. Especially the maths part is definitely difficult. Chemistry, you need to remember so many things and you don't get so much of time in the college. So it's not really recommended. Yeah, this is half of L by 3. So half of L by 3, which is basically L by 6. So quickly you will think, sir, initial energy is mg, but negative because it is below. L by 6. But that is not correct because this mass is not m, it is 1/3 of the total mass. So technically this is m by 3 g L by 6. So it is minus mgl by 18. Lot of people miss that m by 3 or forget that L by 6 and they get a wrong answer. Kinetic energy wise, obviously initially it is 0. Finally, the kinetic energy is half mv square. So I will just say, using energy conservation, using mechanical energy conservation, which says initial energy is equal to final energy. Substitute everything. Kinetic is 0, potential is minus mgl divided by 18. Final is minus mgl divided by 2. This is half mv square. M cancels. So on the right hand side, just keep v square by 2. Shift these people over here. So you will have gl by 2 minus gl by 18 is equal to v square by 2. 2 to 2 cancels. 2 to 2 cancels. GL, take it out as common. So 1 minus 1 by 9 is equal to v square. So it will become GL multiplied by 8 by 9 is equal to v square. So v will be root of this. So velocity will be basically root of this. So it will become 2 root 2. Root of 8 is 2 root 2. 9's root is 3. Root 2 will be multiplied with GL. That is what it is. That is the final answer. 2 root 2 GL, whole thing divided by 3. Its mass is uniform. That's why I can divide the masses proportional to the length. Okay. Great. Awesomeness. How to solve those questions involving small elements? Have I done such questions somewhere? Somewhere in the derivations part somewhere. Yeah, I had done it in the derivation course. Not sure if I've done it before here on the channel. Somewhere I might have done it. Just see, Abdullah, if you can find my old center of mass classes and the derivations part over there. Probably from there you will get some idea. Okay? From there you will get some idea. How to choose even the moment of inertia. Finding moment of inertia, finding center of mass. If you do that, it will be easy. Also do the application of integrations and AOD part. AOD and AOI from mathematics of 12th standard. These are two important chapters which will help you over here. Is that okay, Abdullah? Right. Okay, so this is a beautiful application of this. Now, let's slowly move towards displacement, velocity, acceleration of center of mass. That is the next topic at hand. So say for example, you have some mass 1, it has some velocity 1, it has some acceleration number 1. Similarly, mass number 2 has some velocity, some acceleration. Many such masses are there. This is your nth mass having some Vn velocity, some An acceleration. Their center of mass will also have some velocity as well as some acceleration. Very important thing. Now, just like we know that, listen, the position vector of the center of mass is nothing but, m1 r1 dot 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 like that, mn rn whole thing divided by m1 plus dot 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 mn. Imagine you just differentiate this. Derivative of the position of the center of mass with respect to time. m1 derivative of the position vector of the first mass plus like that mn derivative of the nth mass position. This whole thing divided by m1 plus m2 plus mn. Guess what this will be? This will be rate of change of position of the center of mass, which means it will be velocity of the center of mass. This is rate of change of position 1, so it will be velocity of particle 1. Like that, this will go to mn vn, the whole thing divided by m1 plus m2 plus mn. Now do the same thing again by differentiating velocity, rate of change of velocity with respect to time. So many terms are there, take the derivative everywhere. So derivative of velocity 1 plus m2 into derivative of velocity 2. Last term will be mn into derivative of the nth velocity. Whole thing divided by the total mass. So what you get is rate of change of center of mass's velocity, which is acceleration of the center of mass, which is nothing but acceleration of the center of mass, and that will be m1 dv by dt is acceleration of first particle. Like that, you will have n number of terms, the whole thing divided by m1 plus dot 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 mn. So that's it. That's the formula for moving particles. That's the formula for moving particles. Velocity and acceleration, both. Is that okay, everyone? This was for position. This is for velocity. This we have already seen. So this was position. This was velocity. Lastly, this was acceleration. Now, another important thing is also momentum. See, we just saw VCM is m1 v1 plus m2 v2 mn vn, like that. Whole thing divided by m1 plus m2 till mn. If you shift this over here, you will get m1 plus like that till mn, whole thing into v, velocity of the center of mass. Velocity of the center of mass is equal to m1 v1 plus m2 v2 plus mn vn. Now if you ask me what is this? This is the total mass. This is, what is happening over here? This is mn. This is nothing but the total mass of the system. This is velocity of the center of mass. This is just m1 v1 plus m2 v2 plus mn vn. This equation tells me if each of these terms are nothing but momentums, this is the total momentum of the system, which is also the momentum of the center of mass. So another important thing which you get is the momentum of the system is the momentum of the center of mass, which is the sum of all the momentums, which is just nothing but P1 plus P2 plus Pn. Very important thing. Very, very important thing. Is this clear, everyone? The total momentum of the system is also the momentum of the center of mass. That is, you take the mass and multiply it by the center of mass's velocity, which is also the sum of the total vector sum of the momentum. As simple as that. So, lot of people think PCM is m1 p1 plus m2 p2 upon m1 plus m2. No, it is not. It is just pure vector sum. It's not like m1 v1 formula or m1 a1 formula. Okay, something which you should keep in mind. Now what happens is, if you have many bodies inside a system, each having different masses like this, so this is, let's say, our system. On this system, there could be some external forces. So these are basically F1, F2, F3 like that, Fn. These are basically your external forces. At the same time, there could be even internal forces between the masses. There could be also internal forces between the masses. These are internal forces. The system as a whole will have a center of mass, and the center of mass will have some acceleration. The center of mass will have some acceleration. There is something called as Newton's law of motion for many particles together. That is for system of particles. For a system of particles. Very, very important thing. Usually, when I write F is ma, that equation is written down for a body, for a mass, for a point. But imagine there are multiple points. Then when I write F is ma, is that mass total mass? Is that acceleration of a particle? Is that force as a whole or including internal force? Right? So the answer for that is, it comes out only as the sum of external forces only. That is equal to the total mass, meaning m1 plus m2 plus m3 plus like that till mn. But this is acceleration of the center of mass. So hence, I can just say that the net external force, don't worry about internal forces, is equal to the total mass of the system, and the acceleration that you get, obviously it can't be of a particle, it will be of the combined mass where it is concentrated, that means the center of mass. This is your modified Newton's law for many particles. Again, a very important thing. So I can also mention internal forces. Internal forces can change, accelerations of individual particles. Makes sense. Because if you take mass 1, mass 2, mass 3, for this particle, this force is also an external force. But as a whole, it cannot change anything. So, but it can't change the acceleration of the center of mass. This is very, very important. What it can change? It can change the acceleration of individual particles, but what it can't change is the acceleration of center of mass. That is very, very important. Only external forces can change. Clear till this point? Everyone? Okay. Now, let's basically use this in many problems. Whatever we have learnt till now. Let's use this in all the problems. Okay. One was this slide, the velocity, acceleration, then the momentum, and then this Newton's law. Let's use this. Say for example, there is a mass over here which is going like this with a speed v. There is another mass over here 3m which is going with a speed of 2v. This guy has an acceleration of a over here. This guy is accelerating with 2a like this, okay, or let's say in the same direction, 2a in the same direction. Question is, find the velocity of the center of mass, acceleration of the center of mass. That's the question. Let's try to do this. Let's start with velocity of the center of mass first. The masses are shown, velocities, accelerations are also given, everything in the given terms. Our formula is m1 v1, only two masses are there, so only two terms will be there upon the total mass. What is mass 1? It is basically m. What is velocity 1? It is negative v, because it is in the opposite direction. Remember, it's a velocity, it's a vector, So direction matters. Sign will matter. Plus mass number 2, 3m. Velocity number 2, 2v. Whole thing divided by total mass means m plus 3m. Okay. So what will this be? 3 into 2, 6. 6 minus 1, 5. So 5 mv divided by 4m. So it will be basically 5 times v by 4. That is the velocity. Very straightforward. Let's go to the acceleration part. Let's go to the acceleration part. All right. Acceleration will be again m1 a1 plus m2 a2 divided by m1 plus m2. What is the mass? Okay, m. What is acceleration? It is a. It is positive because it is towards the right. Mass number 2, 3m. Acceleration towards the right, so positive. Whole thing divided by m plus 3m. So what will this be? 1 plus 6 is basically 7. So 7 ma divided by 4m. So it will be basically 7a divided by 4. That is the answer. Clear? How did we find it out till this point? Shall we go ahead, everyone? And if you are new to the channel, quickly subscribe so that you do not miss any classes in the road series. Number 1. Number 2, like the video so that YouTube knows you are interested in JEE and it will keep you away from distractions. Cool? Let's go to the next question, guys. Let's go to the next question coming up on your screen. Can 2-point masses which are in motion have VCM or ACM equals to 0? That is the question. Can their center of mass have no velocity or no acceleration? Is this situation even possible when two masses themselves are moving? I think we have to try it out. Without that, it's just a pure guess. Imagine this is a mass 1. Imagine this is a mass 2. It is having velocity v2. This is having, let's say, velocity v1. So if I want VCM to be 0, which means m1 v1 plus m2 v2 upon m1 plus m2 will be 0. Okay, that means numerator has to be 0. So m1 v1 plus m2 v2 is 0. Therefore, I can say m1 v1 is equal to negative m2 v2. So this should be the condition, which means the momentum of 1 will be negative of the momentum of 2. Oh, only then this is possible for the velocity of the center of mass to be 0, which means one particle should actually be moving opposite in direction, but their momentum should be equal. P1 and P2 should be basically equal. Then you will see that the center of mass is going to be at rest. Definitely. Then the center of mass can be at rest. So then it happens. Make sense? Similarly, for acceleration also you can proceed with that same thing. So if ACOM is 0, then you can say m1 a1 plus m2 a2 upon m1 plus m2 is 0. That means m1 a1 should be minus m2 a2. So if this happens, basically a particle has one acceleration here, another acceleration here, and m1 a1 plus m2 a2 is 0, then you can say that their center of mass is having no acceleration. No acceleration. Is this clear, everyone? Everybody with me? Cool. Shall we go ahead? Shall we go ahead? All right, let's go. Another interesting question coming up on your screen. A particle of mass m has a velocity given by 2 I cap minus t square j cap meters per second. That's the velocity of the particle. Find the velocity of another mass 2m such that the center of mass has no acceleration. Find the velocity of the other mass so that the center of mass has no acceleration. What will you do? Think about it. Center of mass, acceleration. I will need A1 and A2, only then I can do it. So do I know A1? Think, do I know A2? But I don't need A2, I just need velocity. So I have an idea. If center of mass has no acceleration, ACOM is basically 0. That means what can you say about the center of mass's velocity? It is just going to be a constant. It is just going to be a constant. Is that right? Okay. Let's also figure out what is acceleration number 1. Acceleration number 1 will be dv by dt, will be just dv by dt. So derivate that. So if you differentiate it, you will just get 0 I cap minus 2t j cap. That's it. Meters per second square. Since center of mass has 0 acceleration, therefore m1a1 plus m2a2 should be basically 0. Or rather the whole thing divided by m1 plus m2 should be 0. So this means numerator should be 0. Numerator, mass number 1 m. Acceleration number 1 is basically minus 2t j cap. Mass number 2, how much is it? It is basically 2m. Acceleration number 2, I do not know, is equal to 0. M cancels. So shift these guys on that side. So 2 times of A2 bar will be, this negative will become positive, 2t basically j cap. So therefore acceleration number 2 will be just tj cap. Acceleration 2 will be just some tj cap. Till this point clear? But acceleration is nothing but dv by dt. Acceleration is nothing but dv by dt. So dv by dt is basically t j cap. Shift it over here. dv2 is equal to t dt j cap. But do not forget, okay, nothing. So now I'll just have to integrate this. So I don't know the initial velocity of the second mass. So I'll have to assume some v naught over here. The final velocity will be v2. Time will be 0. Final time will be t. So this will be v2 bar minus v naught bar will be equal to t square by 2 j cap. Therefore, the final velocity of the second particle will be some constant plus t square by 2 j cap. So it will be of this form where v naught will be the initial velocity. It will be of this form. Getting my point? How we solved this question? It involved little bit of calculus and also the concept that center of mass motion was involved where acceleration was not there. Where acceleration was basically not there. Got it? Give me a thumbs up. Let's go ahead. Yes, no? Quickly. Let's go ahead. Let's go ahead to the next question coming up on your screen. okay, there are some forces acting on this, and you know, we have been asked to figure out, let's say, the acceleration of the center of mass. Acceleration of the center of mass. So what will you do in this case? Okay, just find out the acceleration of the center of mass, spring constant, etc. not needed. I will think of it like this, that okay, if I take the entire thing as my system, won't the spring force technically be the internal force? Won't the spring force be technically the internal force? Think about it. Yes or no, guys? So it really shouldn't matter when you are trying to find the center of mass's acceleration. So remember Newton's law, modified for system. It is the total mass into acceleration of the center of mass. External force is just 20 Newton in the horizontal, no friction, etc. Total mass will be 2 plus 3. Center of mass will have an acceleration given by how much? 2 plus 3 is 5, 20 by 5, which is nothing but 4 meters per second square. Which is nothing but 4 meters per second square. Is that right? Once you get this, you can find out one acceleration if other acceleration is given. For example, this guy's acceleration is a2, this guy's acceleration is a3. So m1 a2 plus m2 a3 will upon m1 plus m2, which will be acom, which is nothing but 4. 2 plus 3 is basically 5. 5 4s are 20. So this is the equation. So let's say, for example, I know the value of a2 as 1. From this I can find how much is a3. Or somebody tells me, listen, a3 is basically 7. From this I can find out how much this is. So this is the equation, which if this is given, this can be found, or if this is given, this can be found. So those kind of questions can also be solved using this concept. Okay, so you see some spring related concepts as well with connected blocks, where one of the acceleration is given, other acceleration is asked. Cool? Let's go to the next question coming up on your screen. There is a pulley like this. Okay, there is a pulley like this. There is a mass here, another mass here. This is 2m. This is, let's say, m. Question is, find the acceleration of the center of mass. Find the acceleration of the center of mass. Now, looking at the question, it initially feels that why would center of mass even move? Because one is going up, one is going down, won't they cancel out each other? Think about it. You will realize that, okay, yes sir, fine, this mass is accelerating down, this mass is accelerating up, but in spite of it, it will not cancel because the masses are not equal. Masses are not equal, so they can't cancel. Getting my point? So, when you try to find the acceleration, first let's find this value of a. I think this we have done in Newton's laws. That was not a big deal. That acceleration was g into bigger mass minus the smaller mass upon the total mass. That was the formula. G m2 minus m1 upon m1 plus m2. 2m minus m, this is 3m. So basically it will just be g divided by 3. So that's the acceleration. This was using Newton's laws of motion concept. So now let's find what about their center of mass. So center of mass. Upward or downward, you decide. I think heavier mass is going down. So I think we should take downwards as positive. So center of mass 100% will go down because heavy mass is going down, lighter mass is going up. So center of mass goes in the heavier direction. So acceleration of the center of mass will be, mass 1 is 2m, acceleration is a, positive because downwards is assumed as positive, plus mass number 2 is m, acceleration is minus a, be careful. Why minus a? Because it is opposite to the assumed direction, upon the total mass 2m plus m. 2 minus 1 is 1. So it will just become MA divided by 3M. MM cancels, so it will become A by 3. But A itself was G by 3. A itself was G by 3. So hence it will become G divided by 9. That's the acceleration of center of mass. It goes down, and hence the answer has come out to be positive, because that's what we assumed as the positive direction. Perfect. But you know what? There is one more way of doing the same question. See, here we found out A1, A2, then use ACM is M1, A1 plus M2, A2 upon M1 plus A2 formula. So we solved it using that. But guess what? There is another way of doing the same question. You might be wondering how. Yeah. J aspirant, hold on. Please don't spam right now. Just imagine, okay, this is the center of mass. Fine, it will accelerate down. How about me using Newton's law for a system of particles like this? Make this as my system. Then what are the external forces acting on it? Well, there are many actually. One is its own weight, which is 2 mg. Then there is another weight over here, which is mg. Then there is tension coming from here, as well as tension coming from here. These are the only forces. In spite of it, it is going down. That means they are not balanced. It's unbalanced. Downward force is more, upward is less. So the downward forces will be 2 mg plus mg. Upward forces will be tension and tension. This will be equal to the total mass, which is 2m plus m multiplied by the center of mass's acceleration. This is Newton's law for multiple particles. Only external forces will matter. Such a beautiful way of doing it now. You will be like, okay, what is tension? We'll come to it. So this will just become 3 mg. But what is tension? We'll come to it. 3m into ACOM. We have done this previously in Newton's laws again. The tension was 2 m1 m2 upon m1 plus m2 multiplied by g. That is the formula for tension. We have done that in Newton's laws of motion. So if you remember that result, it is useful, or else it will be a pain. Well, again, lot of things get cancelled, like m and this m and this m, of course. So what do we get over here? G is common. Oh, by the way, yeah, even this m will get cancelled here. Even this m will get cancelled. Perfect. So what am I left with? G is common. And over here I have 3 minus 2 2s are, 2 into 2 into 2, that's going to be 8, divided by 1 plus 2, that's 3, perfect, is equal to 3 times ACOM. G. 3 3s are 9, 9 minus 8 is 1, 1 by 3 is equal to 3 times ACOM. Therefore, center of mass's acceleration, 3 comes down, it will become G divided by 9, which is exactly the same answer. This just shows no matter which way you approach, the answer will come out to be the same. Getting my point? No matter how you approach the problem, you will get the same answer. Amazing. Crystal clear how to solve these questions on center of masses, velocity, acceleration, etc. Great. Now, what if I give you a question like this? This was asked in JEE. 2 planets move, or rather of mass m and 3m, move due to mutual gravity. Question is, the velocity of the center of mass will be towards the smaller mass, towards the larger mass, can't say, or 0. 4 options will be towards the smaller mass, towards the larger mass, 0, can't say. Think about it. Yep. Laura, it's me only. All right. Think. The denominator will change. Yeah, you mean here m plus 2m will become 3. Yep, that's it. Same answer we got. Okay. Think carefully. This is one mass. This is another mass. They are mutually attracting each other. Won't that be an internal force? So if you consider this as your system, tell me what is the external force? The external force is a big fat 0. And if external force is 0, center of mass will have no acceleration. Center of mass will have constant velocity, but it starts from rest. It starts from rest. Therefore, center of mass will have that constant 0 velocity. So, center of mass is going to be at rest. That's the answer. Because the mutual gravitational force is an internal force. Got it? Everyone? Swami, this is not your bro. This is your teacher. So say, sir. Show some respect. Okay, cool. Now, there is a very interesting type of or kind of problem that you get from this. What is that interesting kind of problem that you get from this? Let's see. This happens if net external force is basically 0 and center of mass is at rest because of that, then you will see, because center of mass is at rest, that means VCOM is 0. Therefore, M1 V1 plus dot 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 whole thing divided by M1 plus dot 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 is 0. That means numerator is 0. That means numerator, which is M1 V1 plus dot 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 till Mn Vn is 0. But velocity is displacement by time. So, displacement by time plus dot 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 Mn displacement by time is 0. Time cancels. So, I'll get M1 S1 plus M2 S2 till Mn Sn is equal to 0. So, this is a very important result which you should remember whenever the net force is 0 and the center of mass is at rest. This is very useful for solving all those questions where one thing moves, other things motion has to be calculated to keep the center of mass at rest. I'll give you many examples of this, don't worry. Okay, but just remember the condition and the final result. Observe this. You might have seen such questions where let's say a 3 mass system whose center of mass is at rest is disturbed such that mass m moves along x-axis by 2 meters, mass 3m moves along negative x-axis by 1 meter. How much should 2m move? How much should 2m move so that the center of mass obviously should be kept at rest? If you see, the main condition is right over here, center of mass when it is at rest, then I just told you M1 S1 plus M2 S2, as many masses, here there are 3 masses, it's clearly mentioned 3 masses, so till M3 S3 is equal to 0. That is what I gave it to you right over here. If center of mass is at rest, net external force is 0. Okay. What is mass number 1? Mass number 1 is m. What is the displacement towards the x-axis? 2 meters. Okay. Plus mass number 2 is 3m. Displacement is negative x-axis, so minus 1. Plus Mass number 3 is 2m. Displacement is exactly what we have to find out. So let's see what do we get. M cancels, so it will become 2 minus 3 plus 2s3 is equal to 0. 2 minus 3 is negative 1 plus 2s3 is equal to 0. Therefore, 2s3 is equal to 1. Rather, s3 is 1 by 2, which is 0.5 meters. So, 2m has to move how many meters? 0.5 meters. Since the answer is positive, so that means towards positive x-axis. That's the answer. As simple as that. So this equation helps you solve such kind of questions. I'll show you one more example of the same. Observe this. So there is a plank of mass 2m, or let's say 80 kg, and then there is a pandu over here, or let's say over here, of mass 40 kg. This length is, let's say, 60 meters, or let's say 6 meters. This is, let's say, 6 meters in length. And this whole thing, apparatus, is lying on a smooth floor. This whole thing is basically lying on a smooth floor. What happens is, this particular pandu walks to the other end. Question is, how much does the plank move by? If this guy moves here, how much will the plank move by? Now you might be wondering, why will the plank even move, right? Why will the plank even move? See, when the person walks, he is walking because of friction. So the friction will push him ahead, but the same friction will push the plank behind. He'll push the plank behind, that's why he's able to move ahead. So maybe after some time, this plank would have gone here. This plank would have probably gone here. This person would have reached over here like this. This is the other end of the plank. So clearly you can see the plank has moved by some amount. The plank has definitely started from here, it moved behind on this surface. So we have to find how much is this. Okay. So now I'm able to visualize. So now let's start writing the equations. In this process, tell me for our entire Pandu plus plank system, what is the external force? What is the net external force? It's a smooth surface. On the plank, there cannot be any force, and normal mg cancel out each other, so it is 0. And the friction is internal, so it doesn't even matter. Which means the center of mass of that particular system is going to be at rest. Do you guys agree with this statement? The center of mass of that complete system will be at rest. If it is at rest, we know what to do. All I have to do is just say m1 s1, there are only two masses, plus m2 s2, no need of the third term, is equal to 0. Yep. Now, what is mass number 1? Well, it is 40 kg. What is displacement 1? S1. What is mass number 2? It is the plank, so it is 80 kg. What is displacement number 2? I do not know. Is equal to 0. So 40 goes with 80 2 times. So because of which I will say S1 plus 2 times of S2 is equal to 0. Now I will be like, okay sir, S1 is of the Pandu, S2 is of the plank. Sir, I think I already know how much is the displacement of Pandu. You will immediately say, sir, Pandu has gone to the other side, so he is moved 6 meters. So can I say this S1 is 6 meters? Or something is wrong? Can I say Pandu has moved 6 meters? Or that is wrong? I feel that is wrong, and I'll tell you why also. These displacements are from the ground frame, not from the plank frame. Yes, be careful about it. So, really, you should get a hold of this. Pandu has moved from here to here like this. This is S1, this is S2. So, actually S1 is not even 6 meters because by the time he reaches the end has come closer. So, strictly speaking, the displacement of Pandu with respect to the plank, displacement of Pandu with respect to the plank is 6 meters. That is relative displacement. If you are on the plank at rest, you will see the Pandu coming here. Yes, the plank has moved, but for you, he has moved 6 meters. And whenever you find relative things, it's always displacement of 1 minus displacement of 2. So displacement of Pandu minus displacement of the plank, that is 6. This is S1, this is S2, so that is 6. So therefore, S1 is equal to S2 plus 6. So go back over here and try to solve this. S1 is S2 plus 6. That's the catch. So instead of S1, just put S2 plus 6. The remaining term is plus 2S2. That is equal to 0. So therefore, 3 times of S2 will be minus 6. Therefore, S2 will be minus 2 meters. What does minus 2 meter mean? It means the plank moves 2 meters towards the left side. It moves 2 meters towards the left side. Is that clear, everyone? Yes. So that is the catch in these kind of questions. You have to use this concept of relative motion. If you don't use, you will be stuck. You will get a wrong answer if you go directly. Is this clear, everyone? Very good. Awesomeness. Awesomeness. So you have done those kind of questions also. Now, there is another interesting concept. Let's try to do this. Let's say, for example, this is 2 kg mass. Let's say you are moving here with 1 meters per second. There is another 4 kg mass, which is probably moving at 2 meters per second. I want to find the following things. Can you find the kinetic energy of the center of mass? Can you then also find me the kinetic energy of both the masses, K1 and K2 together? Okay, I want to find the total kinetic energy of that system, K1 and K2 together. Then I want you to also find one more thing. I want you to find the relative kinetic energy. This is with respect to center of mass. This one was basically with respect to the ground frame. This was with respect to the ground frame. So all these 3 things I want to find. Okay, let's try to solve this question. Let's try to solve this question one by one. Step by step, let's go. I want to find the total kinetic energy from the ground frame, then from the center of mass frame and everything else. First, let's find what would the center of mass be even doing. Center of mass will have some velocity. The velocity of the center of mass will be m1, let's say 4 kg, into v1, which is 2, plus m2, which is 2. Velocity is -1. Whole thing divided by total mass, which is 4 plus 2. 4 2s are 8. 8 minus 2 is 6. 4 plus 2 is 6. Oh, coincidentally, it came out to be 1 meter per second, but it is positive. So it is going towards the right at 1 meter per second. So if somebody decided to sit on the center of mass and then again re-observe both of these masses, this mass 2 kg, this mass 4 kg, what would they appear to be doing? What would they appear to be doing? Think about it. You are already moving at one right side. So this mass going towards the left side will appear to go at which speed? Obviously 2 meters per second. If you look at 4 kg mass, you are following it with the speed of 1. It is moving away from you with 2. So the relative speed will be 1. So this guy's speed will then become 1 meter per second. Is that so? Everybody able to get that relative motion concept? Yes. Definitely, Gugan, rotational motion will come after collisions and momentum, not before that. Okay, so it will start next to next week, or probably towards the end of the next week, something like that. Okay, now all this is done. So let's try to find each of these terms. Kinetic energy of the center of mass is half total mass into velocity of the center of mass square. The total mass is 2 plus 4 kg. Center of mass has a velocity of 1, so 1 square. So 2 plus 4 is 6, 6 by 2 is basically 3 joules. So that's the kinetic energy of the center of mass. Keep it aside. I hope this is clear. Next, if I just calculate what's the kinetic energy of both of them as seen from ground frame, it will be just half into mass into v square plus half into mass into v square. So which will come out to be 2 cancels, becomes 1. This 4 and 2 cancels, becomes 2. 2 cube is basically 8. So it will just become 9 joules. That is your kinetic energy of that system. Kinetic energy of that system from the ground frame. Perfect. Lastly, let's find out the kinetic energy of both of them as seen from the center of mass. Half mass is 2 kg, velocity is 2, plus half mass is 4, velocity is 1. Some people I know, they have put a minus sign because you thought the velocities are opposite. But I think you forgot that kinetic energy is scalar, so you do not put minus sign there. So don't worry about the directions. Kinetic energies will just add, it will not be minus. Is that right, everyone? So what will this come out to be? 2 cancels, 2 square is 4. 4 and 2 cancels, it will become 2. So this is just becoming 6 joules. So this is kinetic energy of the system as seen from the center of mass frame. Very interesting. Do you see some coincidence, some relation which is happening? 9 is 3 plus 6. I don't know how many of you are able to see that. 9 is basically equal to 3 joules plus 6 joules. Very interesting. Kinetic energy of the entire system is 3 joules, which is kinetic energy of center of mass, plus kinetic energy as seen from the center of mass. This becomes a very important result which you should definitely remember. So the total kinetic energy of a system is equal to, you find the kinetic energy of the center of mass and then add it to the kinetic energy of the system with respect to center of mass. This is the rule which you need to remember. Very, very simple. That is what this question was all about. 9 was 3 plus 6. I wanted you to see that, feel that, what it exactly means, and this is exactly what it is. Exactly, 396. Now, you might be wondering, what are the other applications of this? If I choose to see the kinetic energy from some different frame, not ground, no issues. I can choose different frames. If I choose different frames of reference, out of this, this and this, which one will never ever change? If I choose a different frame, which one will never ever change? The total kinetic energy of the system, I think it will change. Because if I choose a different frame, these speeds will change. So that can change definitely. Obviously, center of mass will have different velocity. Because, why? This number and this number will change. So even this will change. But you know what will not change? Is this. Because this is relative velocity with respect to center of mass. So this number can't change. This number can't change. So therefore, if a different frame, or rather for different frames of reference, it's the kinetic energy of the system with respect to center of mass which will always remain the same. It also means if our frame is center of mass itself, that means the center of mass will be at rest. If the center of mass is at rest, then what will happen? The kinetic energy of the center of mass will be 0, and this is the lowest possible value which you can get. You can't go negative. Kinetic energy is never negative. Out of these two terms, this never changes. This can change, can go up or go down. The least value is 0. That means their sum is the least when you yourself are the center of mass. Therefore, I will say that the kinetic energy of the system is seen to be minimum. In the center of mass frame of reference. A very important result of this. Kinetic energy of the system is found to be minimum when you observe that system from the center of mass frame. So in this previous question, if one were to move at 1 meter per second, you will see the system's energy will be least, and that will be 6 joules. You can't go below 6 joules no matter what. That's the lowest possible energy. Is that clear, everyone? Is this absolutely clear? This concept is also used in rotational motion. Yes, this is also used in the chapter of rotational motion. Correct. Very good. Awesome. So we are done with all the concepts and all the theories and all the applications of center of mass and its motion. So this chapter comes to an end, guys. We'll be starting off with momentum, impulse, collisions, types of collision, oblique collision in the next lecture. Okay, and we'll be doing obviously other things on the way as we progress. Cool. Take care. See you in the next class. Stay subscribed. Stay on the channel. Do not miss any classes. Even if you are watching recordings, it's okay. But be regular. Be consistent. Everything is possible. See you in the comment section. Thank you for liking. Thank you for subscribing. This is Captain Shreyas. Enjoy your dinner.